Hi, my name is Dean Pusick, and during this video I will be giving you a brief tour of ICE, the Integrated Comprehension Environment. ICE is being developed in order to assist reverse engineers in understanding complex assembly code, particularly in the domain of malware analysis, and it will enable reverse engineers to also create sophisticated analyses that are both static and dynamic. Let's begin by first opening ICE. Our first task is going to be to select a file to work with. For this demo, I have created a couple versions of string length, and what we'll do is we'll just look at the first one. So here we have the first implementation open, and you can see on the left here the x86 code. As you see, this implementation is fairly straightforward, and all it does is just looks for a null terminator and then does a subtraction to compute the number of characters. ICE, as I was saying, is intended to be quite versatile, and in order to support more than just x86, what we use internally is a representation called Rail, which is a reverse engineer's intermediate language. It was developed by a company called Zynamics, and through this little module I've created, I can show you what it looks like. We'll just make this a little easier. There we go. So on the right here we have the Rail code that corresponds to our x86. These first four lines that I have highlighted are the translation of the move instruction, which was getting the parameter off the stack and putting it in EAX. The remaining lines just continue through and continue through by translating each x86 instruction into usually several Rail instructions. The reason that we went with Rail is because, or rather more an intermediate language, is because it allows us flexibility in terms of what instruction sets we can support, and it also means that when people are writing analysis modules, they are able to work with one single language rather than trying to support a whole bunch of them. As an example of what an analysis module actually looks like, I have here the code for the instruction printer we just saw. The first thing to notice is that this code is written in Python. We went with Python because it is so widely used, and because also it's just a great time to play with. An analysis module in ICE is required to have three functions implemented. The first function is module init. Typically you would use this to create whatever initialization and objects you need for the rest of your analysis. The second function required is module exit. Again, this is kind of where you should be doing your cleanup and destroying anything you don't need anymore. The most interesting of the ones required is this one called analyze. This is what's called when you actually want your analysis to be started, and in this case what we're doing is we're just printing out the instructions. In order to do this, we first need to get the instructions, and we can do this by calling this getAllIce instructions function. This is implemented inside ICE itself, and it actually retrieves the instructions for you and returns them in a nice little list that you can use in Python. The next thing that we do in our analysis here is just iterate through the list and call a function called writeInstruction. All this does is just kind of work its way through the instruction and print it out into the console in ICE. Once again, you'll see that we have a different function here. We have IceUI.writeConsole that just writes whatever string it gives to the console. What I'd like to show you is an analysis module my colleague wrote that actually simulates the Rail instructions. Once again, I've opened up the implementation of string length that we saw earlier, and we have it here on the left. We begin by now going into our analysis modules and actually translating this into Rail. You'll notice that this looks a lot like the output that we had for the instruction printer before. However, there is a little more info there, and it's just a little easier to read. With that, we then go back up to our analysis modules, and this time what we do is we select Simulate from the list. When we do this, the Rail code is actually run through a simulator, and we get this output here. So the interesting thing about this is that if we look in the return register, which is EAX, we see the value 4. And that's because the instructions were executed in Rail and it actually was able to compute the value of the number of characters in the string. The string that we used was this word here, Andy, which is located in our memory. So with that, that is a brief tour of ICE, and there's lots more to come, and we're actively developing it, so it'll be exciting to see where this goes in the near future.